Welcome to Math Master. This is SARITHA. Today our topic is types of quadrilaterals. We have different types of quadrilaterals and we will discuss one by one and their properties in detail. Okay. So the first one is trapezium. So the first quadrilateral is trapezium. What is a trapezium? Trapezium is nothing but it is a quadrilateral in which one pair of opposite sides are parallel. See, you take one quadrilateral. Okay. So this is a quadrilateral ABCD. Okay. So this is a quadrilateral first of all. Then in which one pair of opposite sides. So this AD and BC and AD are opposite sides, right? As well as AB and CD are opposite sides. So in the two pair of opposite sides, if at least one pair of opposite sides are parallel, then we can say that this quadrilateral is a trapezium. See, we denote the two sides are parallel. If the two sides are parallel, we denote with an arrow symbol for those two sides. Okay. So this BC and AD are parallel. So this is one pair of opposite sides. So what is a trapezium? If one pair of opposite sides are parallel in a quadrilateral, then we can say that quadrilateral is a trapezium. Okay. So now tell me whether Now tell me whether this figure is a trapezium or not. See, so these two are opposite sides. Yes, these are parallel and these two sides are also opposite and these two sides are also parallel. Now we need only one condition that at least one pair of opposite sides are parallel. But in these two pairs of opposite sides are parallel. So no problem with that. We don't have any condition on the second pair of opposite sides. We have only one condition that one pair of parallel sides are enough to show that it is a trapezium. So this parallelogram is nothing but a trapezium. Yes. Now, is it a trapezium? Yes, in the rectangle, we know very well that the opposite sides are always parallel. Okay, so we don't need anything. We just have only one condition, that is the one pair of opposite sides are parallel. Yes, this rectangle is also a trapezium. Yes, this is a rhombus. Is it a trapezium? Yes, it is a trapezium. In that rhombus, all the sides are equal and all the opposite sides are parallel, isn't it? That is why we can say that it is a trapezium. What about a square? Square is also a trapezium. Yes, and these are the different types of examples of trapezium. Okay, so parallelogram is also a trapezium. Rectangle is also a trapezium. Rhombus is also a trapezium. Square is also a trapezium. Okay. Now we'll see an example for which is not a trapezium. Is it a trapezium? Is it a trapezium? No. This is not a trapezium. Okay. This is not a trapezium and all these are trapeziums. Okay. Now we'll see what are the different properties of this trapezium. So properties of a trapezium. The first property is you take one trapezium. So these two sides are parallel, AD and BC. Okay. So one pair of opposite sides are parallel. So this angle A has arms AB and AD. Okay. and this angle B has arms AB and BC. So these two angles have a common arm AB, isn't it? So as these two are parallel sides and AB, CD, we call them as a non-parallel sides. Okay, AB and CD are non-parallel sides. So the first property is the angles which have a non-parallel side as a common arm. See, these two angles, okay, these two angles have non-parallel side. Okay, this non-parallel side as a common arm. Okay, those two angles are always supplementary. So what is the first property? The adjacent angles. These two are nothing but adjacent angles, right? The adjacent angles which have non-parallel side as a common arm. The two angles are always supplementary, which is nothing but angle A plus angle B, sum is equal to 180 degrees. So what about angle C and angle D? See, this CD is a non-parallel side and this is a common arm for these two angles, angle C and angle D. So that is why these angle C and angle D are also supplementary, which is nothing but angle C plus angle D, which is also equal to 180 degrees. Okay, so these two are supplementary as well as these two are supplementary. This is the first property. How can we say these two angles sum is equal to 180 degrees only? See, as this AD and BC are two parallel lines, so we can take this AD as a transversal line, isn't it? This line is intersecting these two parallel lines at two different points. That is why we can say this AB is a transversal for these two parallel lines. Okay, so what are these two angles for this transversal? These two angles are co-interior angles. For this transversal, we have a property that the co-interior angles are always supplementary. So that is why we can say this angle A and angle B are always supplementary. So from that we can say these two are always supplementary. Okay. Okay. So the second property is, see, this AB is a non-parallel side and CD is a non-parallel side. You take the midpoint of these two non-parallel sides. See, let us consider this is the P, point P. It is the midpoint of a non-parallel side AB. Okay, these two non-parallel sides may be equal, may not be equal. So we don't have any condition on the non-parallel sides. Okay, so I am considering the midpoint of AB and I am also considering the midpoint of CD. Okay, this I am taking as a Q. If you join a line of these two midpoints, this is a line segment joining these two midpoints and this we call it as a median of a trapezium. The line segment joining the midpoints of the non-parallel sides, that we call it as a median of a trapezium. Okay, so sometimes we need to calculate this length of the median. Okay, so for that what we are doing? We are drawing a diagonal of a trapezium. Okay, so in order to calculate this length of the median, I am drawing a diagonal for this trapezium, okay, which is nothing but joining the opposite vertices. Okay, this B and D are opposite vertices. This is BD is a diagonal of this trapezium. Okay, so I am taking this point as a R. Okay, now how can we calculate this length of the PQ? Which is, this PQ is nothing but PR plus RQ, right? So first I am considering this triangle, ABD triangle. In triangle ABD. So as this is a midpoint and I am drawing a parallel line. This joining the midpoints nothing but this is parallel to this side, right? So according to the basic proportionality theorem, what is that? But this is a midpoint and this R is also a midpoint of the diagonal. I am joining these two midpoints. So this is parallel to the third side as well as exactly half of it, right? So that is why. So I am drawing this triangle here. Okay. So I am considering this ABD triangle here. Okay. So these two are midpoints. This P is a midpoint of this side and this R is a midpoint of this. So this is parallel to the third side and exactly half of it. Okay. So which is nothing but half of AD. This PR length is, this PR is equal to half of AD. Okay. Now you consider this triangle, BCD triangle. Okay. Is a midpoint of this side and this is a midpoint of this side. I am joining this. So this is exactly parallel to BC as well as exactly half of it, right? So that is why this RQ is equal to half of BC and this is equal to half of AD. Okay. So now RQ, which is equal to half of BC. So what we need? We need a length of the median, which is nothing but PQ. So PQ is equal to PR plus RQ, right? So what is PR? Half of AD. What is RQ? Half of BC. Okay. Now which is nothing but half of AD plus BC. Here, what are AD and BC? These AD and BC are two parallel sides, right? So, these AD and BC are parallel sides. So, how can we define the length of the median, which is exactly equal to half of the sum of the two parallel sides? If he gives the parallel sides, we can calculate the length of the median by exactly half of the sum of the parallel sides. Okay? And the third property is, see, I am considering a trapezium. In this, AD and BC are two parallel sides. Okay. And this non-parallel side, AB and CD. Okay. Now I am drawing two diagonals of a trapezium, which are nothing but one is BD, yes, and the other is AC. Okay. Now I am taking the midpoint of the diagonal BD. So which is exactly here. Okay. P. I am taking the point P, which is nothing but midpoint of the diagonal BD. And I am also taking the midpoint of diagonal AC, which is Q. Okay. These two are midpoints of the diagonals of a trapezium. I am joining these two midpoints. Sometimes we need to calculate length of this line segment which is joining the midpoints of two diagonals. So how can we calculate this length of the PQ line segment? We'll see. See, I am extending this line. So for this, as it is R, and I am also extending this to somewhere here. This is the midpoint of S. Midpoint S. Okay. This is a midpoint for this line segment AB and this S is a midpoint of CD. Okay. Now I have to calculate PQ. See, just now we have seen that this RP length, which is nothing but half of AD, right? Half of AD. And this QS length, this triangle ACD. Okay, in the ACD triangle, what happens? This QC, QS is nothing but half of AD, right? So this is also equal to half of AD, isn't it? See, for this triangle also it is a base. For this triangle also it is a base. That is why this is half of third side. This is also half of third side according to basic proportionality theorem. So okay, now I want PQ, right? This PQ is equal to the total RS length. This RS is nothing but what? This is a midpoint, this is a midpoint. This RS is nothing but length of the median, right? Okay, RS. From the total RS, we are subtracting this part and this part. Then we can get this, okay, which is nothing but minus RP and minus QS. Okay, so what is RS? What is the length of the median? Just before we have calculated, which is nothing but half of sum of two parallel sides, which is nothing but AD plus BC, sum of half of sum of two parallel sides. Okay, minus what is RP here, which is nothing but half of AD, right? Half of AD. And what is QS? It is also half of AD. Now simplify. Half AD plus half BC and minus AD, which is nothing but half of BC minus AD. What are these BC and AD? These two are parallel sides of a trapezium. So now I am what is the length of this line segment PQ, which is nothing but half of the difference of the two parallel sides. So why do we need to denote it in the modulus? Because as this PQ is nothing but length of the line segment, length cannot be in negative, right? So we don't know which side is greater, whether BC is greater or AD is greater. So that is why we always represent this difference in the modulus form. Okay. So that is why length of this PQ is simply half of the difference of the two parallel sides. Okay. By this we can calculate this length of PQ. Okay, this is the third property. The fourth property is you take one trapezium, you draw two diagonals of a trapezium. Okay, so this is one diagonal and this is another diagonal. Okay, this is the intersection point of these two diagonals. Okay, so this is the intersection point of these AC and BD diagonals. So how these diagonals intersect? So always in the trapezium the diagonals intersect in proportional. How can we prove that the diagonals are always intersects in the proportional? Now we will prove. See, you take trapezium and BD and AC are two diagonals of a trapezium and this O is a intersection point of these two diagonals. I am drawing a parallel line from the intersection point of diagonals to the one side of this. Okay. So I am taking this triangle as in triangle ACD. Okay. This is a triangle ACD. I am drawing a parallel line for AD. Okay. This is a AD line. So I am drawing this OP is a parallel to AD. What happens if you draw a parallel to the base? This line divides these two sides are in the proportional. According to Thales theorem, what this line divides these two sides are in the proportional, right? So which is nothing but OC divided by OA, which is equal to CP divided by PD. Okay. Now you take this triangle BDC triangle. In triangle BDC, what happened? Same, this OP is parallel to BC and this divide this BD and CD in the proportional. Okay. So how can we represent? BO by OD, which is equal to BO by OD, which is equal to CP by PD. Isn't it? CP by PD. So, in 1 and 2 equations, CP by PD, CP by PD, we can equate these two, right? So, which is nothing but OC by OA, which is equal to BO by OD. Okay. So, what is OC here? OC is nothing but the part of a diagonal AC. And what is OA? Other part of a diagonal AC. Okay. And what is BO? The part of a diagonal BD. And what is OD? It is another part of a diagonal BD. So, from these, what we can conclude? So, in a trapezium, the diagonals are always intersect in proportional. Means the parts of the diagonals intersecting in proportional, which is simply OC by OA is equal to OB by OD. Okay. So, we can conclude this. This is one more property of a trapezium. Our next property is, so this is a trapezium. If these AD and BC are two parallel sides of a trapezium. Okay. So I am drawing a parallel line to these BC and AD. So, okay. I am drawing a parallel line. This is not the midpoint. This can be any point. I am just drawing a parallel line for these two parallel lines. Okay. So this is a parallel line I am drawing. So how this parallel line divides the non-parallel sides. So this parallel line divides the non-parallel sides in the equal ratio. So that we have to prove. In order to prove that, I am considering a diagonal AC. Okay. So this point, I call it as a O, and these two are PQ line segment. So I am drawing this PQ line which is parallel to BC and AD. Okay, this parallel line divides these non-parallel sides AB and CD in the proportional. So which is nothing but C. Which is nothing but AP by PB, which is always equal to dq by qc. So how can we prove this? We have to prove by this. See, you take this triangle, ABC triangle. In triangle ABC. Okay. So what happens according to Thales theorem? If you draw a parallel line to the base, then this parallel line divides these two sides in the proportional, right? So I am writing this AP by PB, which is always equal to AO by OC, isn't it? AO by OC. Now you consider this triangle. So, okay, this triangle, ADC triangle. In ADC triangle, what happens? This is a parallel to AD. That is why this line divides these two sides are in their proportional. Okay, so which is nothing but AO by OC, which is equal to DQ by CQ, DQ by CQ. From in these two equations, AO by OC, AO by OC, these two are equal, right? We can equate these two. So, which is nothing but AP by PB, which is equal to DQ by CQ, DQ by CQ. So, from this what we can conclude? We can conclude that this parallel line segment divides the non-parallel sides in the equal ratio. Okay. This is the property of a trapezium. Our next property is, this is a trapezium. I am drawing two diagonals, AC and BD, and this is the intersection point of the two diagonals. I am drawing a line which is parallel to BC and passing through the intersection point of diagonals, which is nothing but this is a line I am drawing which is parallel to the parallel sides and passing through the intersection point of diagonals. This line segment is PQ. So what this PQ, which is nothing but joining the non-parallel sides, and it is parallel to the parallel sides and passing through the midpoint of the diagonal. So this PQ line segment always in harmonic mean with BC and AD. Okay. How can we say that AD, PQ, BC are in harmonic mean, which is nothing but AD, PQ, BC are in HP. How can we say 2 by PQ, which is always equal to 1 by AD plus 1 by BC. This AD and BC are parallel sides and this PQ is a line segment which is parallel to parallel sides and passing through the midpoint of the diagonal. So these three are always harmonic progression. Okay. Thank you.